I will give you some examples of use cases where we see this technology really fitting in. Before that, just sort of reiterate the idea that moving data is not inexpensive. So beyond the idea or beyond the fact that you can, there are delays in accessing data. In many cases, there's cost in terms of revenue opportunities. We talk about drug discovery as one of the just examples of the sooner you can bring a drug to market, the more time you have to actually recoup your revenues based on your patents. I think that's true for many other industries where timeliness is really important. There's probably a reason why we have that expression, time is money. In any case, so this is just to demonstrate the amount of time it would take you to access the data if you had a 100 terabyte data set, if you had to move it over TCP versus UDP. And of course, with our technology, it would be right there. So this is the use case that Steve has been talking about. Predominantly, we call it reach-in or in-place data processing. Again, talking about remote locations. And this can be anything from, we talk about edge computing, so data being created by IoT devices, and you need to process the data in real time. I like to oftentimes use the example of, it's a sad example, but it is a fair demonstration of this. Video surveillance data. So I think it was the Parkland shooting where video surveillance data was available, but the video was actually being transported to AWS, to the cloud, to be processed. And there was a 30-minute lag between the video capturing what was happening inside, let's say, the building, and the information as to what is happening being sort of translated back to the folks outside who are trying to figure out what's going on inside. So a 30-minute delay was quite significant and obviously had a significant impact. Not all applications and not in all cases, time is that critical. But the idea that you can now perform, whether it's artificial intelligence or training, or you can just access data in the time that your business needs it, it's a critical and a special thing that we have not been able to do. And of course, as a result, we eliminate a lot of not only the infrastructure costs and due to inefficiencies, but we also enhance our ability to bring decisions, to make decisions, to bring products to market, and to monetize the data in a way that we need to. And again, talking about empowering the edge, I guess edge is a big thing right now. One of the other applications, and this is more maybe from the analytics perspective, is if you're capturing data in multiple locations, you can do initial, first path inference analytics on the data on wherever it is. But the greater value may come from actually being able to correlate data across multiple instances or across multiple sites to have a bigger, better view. I like to think that when I am ready to leave my house and drive from Boston to, let's say, New York City, which should take me 3.5 hours based on legal speed limit and the distance that I have to travel, that when I put in into my GPS and I say, okay, get me to New York fastest possible way. And at first it's going to say, okay, it's 3.5 hours, let's go. And as I progress, I don't want to be able to, I don't want to be stuck in traffic all of a sudden without understanding of why am I stuck in traffic? And I just lost half an hour and my GPS didn't tell me, oh, there was an accident. Oh, there was something else. Maybe if they knew it in time, they could have rerouted me in a way that I would bypass the traffic and save myself the half an hour and get there in 3.5 hours rather than 5, which is typically what happens going through Connecticut. So again, the ability to gather information and analyze information from multiple locations simultaneously can give us a lot greater value and insights across many industries. this is a big one. So accelerating cloud adoption is the way I kind of talk about it. There are many organizations that want to say, hey, I want to go to the cloud, but how do I move my 100? We actually had this conversation this morning about a customer who has, I think they have multiple petabytes of data on-prem, and there's a directive to move it all to the cloud. Well, how do you move petabytes of data to the cloud if you want to run an application in the cloud? Typically, you ship an array. They ship you an array, you download your data, and then you ship it back to the cloud service provider, and they'll upload it into their environment, and that can take months. And also, as both Steve and Harry mentioned, that every time you move copy data, you're potentially exposing yourself. You just lose the control over the data that you would have otherwise. And so the security risks increase. What if, and of course, once you move it into the cloud, you're to some extent locked in using that cloud for compute. Why? Well, because moving data out of the cloud, and if you have multiple petabytes, is going to be quite expensive due to the egress costs. So that's one use case. Another case, I have data that, whether it's data sovereignty, regulatory rules, governance, security, whatever it is, the data cannot leave on my premises, which means that cloud is no longer available to me to leverage all the great tools that are available, applications and resources. Now with Vcinity, what we're enabling in both of these situations and in many others is to deploy the compute wherever it is most applicable, wherever it makes most sense. So if it's in this cloud, that cloud, on premises, at the edge, it doesn't matter. But what it enables us to do is then access the data that is on premises without having to move it. So now if you do want to take advantage of cloud compute but you can't move your data into the cloud, there is an option. If you have, petabytes of data that you don't want to move into the cloud because you don't want to get locked in, or it's going to take months before you can actually extract any value from it, we can help you there. And even if you did move your data into the cloud and now you want to use another cloud for compute, we can help you there as well. So we create a much more connected enterprise regardless of where your data resides and regardless of where you want to deploy your compute. So now you have options, and you can definitely leverage the resources that are available to you wherever they are. What does that do? Well, it creates a hybrid cloud environment. In a disaster recovery scenario, oftentimes, the old SunGuard, and I'll talk a little bit about that yet, but we want to have a hybrid option. We have compute and storage on premises, and we want to burst into the cloud for a few days or a few months or for a particular workload to test something. What we don't really talk about is that in order to do that, you got to get data into the cloud as well. And depending on how much data you need to move, it's going to take some time. So again, with Vcinity, by deploying the bookends, one in the cloud, one on premises, you can actually do the true burst from a compute perspective that you always wanted to do. And you can do it in real time, where you don't have the delay and the time lag of having to migrate the data first before you can actually do anything with it, before you can start running your application in the cloud. And if you think about it, the bigger the data set is, and the bigger the latency on your network, the more time it's going to take for you to move that data. So when we talk about another use case is for disaster recovery and data protection, and obviously we can move data faster than anyone else, which means if you have an SLA where you have to complete your backup both to a local copy and a remote copy within a certain time parameter, we can definitely help in fulfilling that SLA. But what is also interesting is many organizations either replicate their storage arrays or they replicate data between multiple locations for disaster recovery, or they create copies. And some of the newer data protection platforms, the whole copy management, I think Tifio actually brought that to market, messaging to market initially, which is, if I have your data, I have a copy of your data, why don't I make it accessible to your applications to do test and development, reporting, or whatever you need to use this data for? Which means that the repository for backups is actually available to be used and as a storage repository for applications to run directly against. And so in these cases, as well as where data is being just replicated between locations, your RPO and your RTO are, how long is it going to take for me to bring my data back, recover it, and how much data am I going to lose in that scenario? So we're adding another sort of concept to the list of RPOs, recovery point objective and recovery time objective, which is access time objective. In this scenario, it says, okay, so I have my data, I have a copy of my data, and maybe in a backup scenario, how long is it going to take me to recover the data or restore the data from my backup repository into something that represents active storage tier that the application can consume in case it can't do that natively. The next question is, well, what about compute? What about bringing my applications up and start running? So the old SunGuard motion has been, it's been a while, but in many cases is, well, I'll subscribe to some, hardware. So if I have a failure, I'll be able to leverage those servers to run my applications. And I'm going to pay a relatively hefty fee for that. With Vcinity, what we're enabling you to do is, if you have a need to access the data, you can now deploy and leverage, whether it's the cloud, whether it's a hosting provider, or some other location where you might have compute resources running, to now restore your access to data in real time. So you have your recovery point objective, the minimum amount of data you want to lose. You have recovery time objective, the minimum amount of time you want to recover your data from a backup. And now you have an access time objective, which is how quickly, which is immediate, of course, can I access the data in case something happens to my data center. This is something that I think it was Harry who alluded to, is that, and Steve mentioned that, we can run over basically any network. And we have done much testing and have provided support for satellite connectivity. And we just recently did a proof of concept. I think one of either Steve or Harry or both alluded to this earlier, which is there was a 500 megabit link. It was a 500 millisecond latency. And with Vcinity at both ends, we were able to see a sustained 95%, 90 plus really, percent throughput, sustained throughput, which means that you could either move data at 90% of 500 megabits at 450 megabits per second, or you could even, in many cases, work or have applications access data, live, or work on files in real time over the link, because again, after the first byte, the latency goes down to what you would typically experience in a LAN environment. So just a thought, the other day, somebody mentioned to me that Elon Musk is looking to deploy lots of satellites to bring connectivity to every corner of the world. And the first reaction I sort of said, that's great, but you still need to, from the satellite, you still need to connect. Well, maybe there's a play for us there to, to really bring that connection and to enable applications to actually run over over the satellite links that Elon Musk eventually will deploy. We'll see what happens. So just to finish up, we have what we're bringing to market is the ability to access data in real time. We're eliminating the effects and the intermittent latency over the WAN. We enable applications to run directly against data without having to move data, without having to create copies, pass it, or anything else. Yes, John?
My question is, when you talked about your satellite uplink and downlink, is that a physical? Was that a physical link, or was that a VM?
Yeah, we've done both, and we can do it either way. The reality is, we've what Noemi was alluding to was one particular test, John, for one particular customer, but we've also done it at 44 meg at 650 milliseconds of latency, 10 meg and I forget 250 milliseconds of latency, and we still perform at 95+% of actual data throughput. The thing I alluded to earlier, you can imagine, was one of those about being able to see what was going on this moving thing via satellite. So,
no, I was just thinking about my use cases for emerging countries in West Africa, and
sure.
where great broadband is at a premium or non-existent, and a situation like this would definitely help in, for Nollywood or some other applications that might come up. Thank you.
Absolutely. You're right on. And this is kind of what I was alluding to in my comment about Elon Musk wanting to put up a bunch of satellite links or satellites up into space to give connectivity everywhere, which is great. But again, the latency of a satellite link is still going to preclude you from doing preclude you from running many applications because of latency. So having Vcinity in there is going to actually help the satellite link become not just, hey, I need to access a file or something that is sequential, and maybe you can buffer it or cache it, but you can actually start operating and running applications. I'm not saying that you can do it, based on available satellite network, but it does definitely extend where you can access data and where you can run applications and what you can do.
As a follow-on, would this be sort of a sort of solution that, say, an ISP out there could use with dedicated devices, a one-to-many sort of thing where you have a bunch of users out there, separate locations, but you said your Vcinity really doesn't require all of them to be at the same physical location. But if they have authorized devices, if that's how you put it, would they be able to gain the benefits of using Vcinity being in the network architecture?
I would think so.
Yeah. And remember, some of the other things is, define the endpoint, right? You could regionalize the endpoint, and if the remote clients are within a couple milliseconds of some kind of aggregation point, you can put the Vcinity thing there, right? And then they get they essentially have local access to that, but we've removed all the distance beyond that, right? So there's a lot of different ways to kind of play this, but yeah, absolutely.
This is about remote work collaboration when you think about it, right? This is, as I call it, if you're just a typical Office 365 user, it's probably not worth implementing the Vcinity technology. But if you have any kind of workflow, you're doing CAD CAM files, you're doing video files, you're in healthcare, you're in life sciences, you're in finance, doing all kinds of analysis of data sources coming in from everywhere. This is the kind of place where we excel and we add tremendous value. Right. And if I could just make one last comment, and I'll turn it back to Noemi to close it up. So it's interesting. I used to have a saying that, if I could change the world so that you could travel from New York to Beijing in 150 milliseconds instead of 15 hours, would that change the way you do business? Well, the answer is I can't do that for you, but we can do it for your data, right? And I want you to think about how that could change the world. And I'll leave you with this last thought. We've been chatting with a very interesting other startup company And the way they refer to us is we're data teleportation. I think someone used the Star Trek analogy earlier. That's how we think about ourselves too. We make data appear where it needs to appear, right? With all the security and permission and ACLs, et cetera, in the enterprise. But that's fundamentally what we try and do.
I have a question, and this is kind of related to, one of the components is, we've seen what you guys are really good at. Like, you got unstructured data, it's very large sequential files. You're phenomenal at it. Are there any specific case studies or areas where you are not as good? I'm thinking like database and random reads, writes, and stuff like that. So,
yes, so the databases, we're not really, although we do have a customer who did deploy our technology between 2 instances of Oracle RAC, but we don't really talk about it. But yes, so we're not going after databases. We're really, unstructured data is where we're sitting. Now, there are potential work opportunities where, for example, if a database is mounting a file to run queries again, like temporarily, there could be those kind of use cases, but they're not the traditional database, application mounting the database and transacting with it. That's not something that we support today.
Yeah, Jason, just to kind of add on to that, Noemi's, spot on. Anytime you're doing any kind of like high frequency trading or database queries, we're so small, we're not going to add that. If you want to just migrate back up, anything like that up the entire database set, no problem. The other thing that we really don't shine on is streaming data. We're not going to do anything with streams, right? Now, remember I talked about that data prism where I can encrypt it and spray that, we can do immense things with that from a stream perspective. But aside from that, we're not really going to speed up, streaming types of things.
This is Tony. I have a question. Do you guys white box this product? You know what I mean? Can it be baked in and integrated into another product or a larger solution or a larger system and sort of just become part of another product? Or is the only way to work with you guys is by buying Vcinity and working with that product?
The answer is absolutely. And we let's just say we're in a number of those kinds of discussions already. We're out to change the world. I know that sounds crazy, but we think we are a paradigm-changing technology. And part of the strategy is to figure out how to make this technology accessible to as many human beings as possible and or artificial beings or whatever it is, humanoids, as some of my crazy scientist friends like to say, as possible. Because if you think about all the advances that have gone on in compute and applications and AI and machine learning, a lot of them are still dependent on time, the time it takes to get access to data. If we break that one, we're not defying the laws of gravity or physics, but we're trying like hell to come close.
You guys are going to have a lot of OEM opportunities present themselves to you.
Well,
Thank you.
Bring them on.
That does sort of dovetail into a question I had, which was about pricing and packaging. So if I how roughly what am I looking to spend? How do I buy this, and how is that purchased? So I assume that this is a capital expense where I acquire some appliances or VM things of some sort, or do I rent it from you at a per month price? How does that work?
So this is going to sound like a marketing answer, but it's a real answer. We're going to sell it to you how you as a customer want to buy it, right? We have customers historically, especially before before 2020, we didn't have the virtual machine version, right? So you needed some software and a physical appliance. Now you don't, depending upon the application. So we have customers who have subscriptions. We have customers who buy traditional, they buy hardware on CapEx with sort of annual, support and maintenance thereafter. We're consumption by the hour in the public cloud marketplaces. We've been talking, honestly, we've even discussed revenue sharing kinds of approaches with different kinds of customers. Back to, I think Lord John said something about, ISVs or other potential partners. The short answer, Justin, is what we want to do is we want to sell how the customer wants to buy. And that varies. It does. We find that today across verticals, across it. We've run into some commercial companies who are like, we only buy CapEx. Okay, fine, we'll sell you CapEx. Others are more than happy to do some form of subscription or OpEx type of expense. And the cost, by the way, ranges from, it's hard to give a range because it depends on the size of the enterprise. And it also depends on how many locations, what kind of connectivity you're putting in. But at the low end, in the VM, it's, in the range of hundreds of dollars a month to, if you're a big enterprise, if you're one of the world's largest pharmaceutical companies, it's going to cost you a lot of money to implement this, but it's going to save you an incredible amount of money, right?
Yeah, it was more to understand the model that it follows so that you've got an idea of how does it align with the kind of value I'm getting. So I can think about what kind of value you need to deliver to me when I'm figuring out if it's worth it.
Absolutely.
So Harry, I'm trying to summarize all this in my head and think of all the possible applications that this could be leveraged for. And I just want to make sure I understand this right. You guys are really decoupling compute and storage, right? And separating them, not just by a little bit space in the data center, by making it so that they can operate as if they were on the same machine, but by a large geographic distance. Mm-hmm. So what kind of compute needs to be on the storage side, right? If I'm decoupling compute and storage, do I just need like a little bit of compute, or do I need a large number of servers to drive your Vcinity platform to be able to integrate with storage? I mean, what Steve, actually needs to be there? Can I just put a Raspberry Pi in front of 2 petabytes of storage and be good to go?
No, not a Raspberry Pi. Steve, you want to take that one?
Yeah, actually, we have run on the Raspberry Pi, so we're okay there. It really depends on what you want to do.
But not on petabytes of data. Come on.
Well, but really, I mean, if you only access it a little bit, that's okay. But it really depends on what you want to do from an application perspective, right? And the beauty behind what we're doing here is we're saying, we really don't care, right? You have whatever your mission, your business model needs from a compute and application perspective. These are the things that I need to do for me as a customer. We'll just bolt right into that, right? So it could be everything from, I have a Raspberry Pi that only needs one little bit of data once in a while, to I have a server farm that needs to move hundreds of gigs and terabytes and petabytes of data. Our job is to decouple our requirements from that, right? It's to say, we're essentially the glue to whatever you particularly need from your business perspective. Does that make sense?
A little bit. I guess what I'm trying to get at is there, in order to drive the Vcinity platform, do the encryption, tunneling, all that sort of stuff.
Okay.
How much actual compute does that take? And does that compute scale with the amount of storage that it's working with? If I'm dealing with 1 petabyte versus 2 petabytes, do I need 32 cores or 64 cores? I mean, how much compute do I need on the storage side if I'm moving my compute to the remote end where that's actually interfacing with the user?
Sure. So let me give an example. So for our VM, it's 4 cores, it's 16 gig of memory, and whatever you need for the OS, right? So that's kind of the minimum footprint behind that. One nice thing about the technology, and it really is afforded to us through scale, is it's a clustering technology. So that if you start out at one spot, you need to grow, I'm adding more users, we just keep adding more members to the cluster, right? So you can scale non-disruptively. That's one of the benefits behind it. But we're, right now, like I say, it's the VM is the smallest footprint. We're trying to get into an app space, which is a little bit different. But, I think 4 cores and 16 gig of memory is pretty thin, right? That's the minimum of what you want to do. Now, again, if you want to move more data or do more things or have more users, then we'll just add more to that cluster. Does that help? That answer the question?
Yeah. I think that was more along the lines of what I was expecting.
Cool. Yeah, thank you.
Would it make sense for you to license your technology to third-party storage vendors to integrate it, for example, into their filers, to have this kind of distributed, federated kind of infrastructure? I see you're smiling, so maybe it's not that naive. Maybe it's not that naive.
No, it's a good question, and the answer is yes, of course, right? And there's a lot of different ways to play. So specifically the OEM storage vendors, right? They're struggling because the hyperscalers are taking the storage business, right? So if I can empower people to say, look, I want to keep my data on-prem, which means I'm increasing my storage on-prem, well, that's empowering the the OEM storage providers, right? So there's a good play there. The other one is, you can create differentiation. You can say, you know what, I pick the OEM of choice. Now I can link things together in a way that was never possible before. I can do unique things, and I can add a differentiation that says, hey, look, if you put this storage in, not only can it perform a billion IOPS locally, but you have an approach where remote users can get to it as well. So yeah, we're walking down those paths. It's not a naive question at all. That's I want to let Harry expand upon that, but that's very insightful. Yep, absolutely.
Yeah, I'm thinking about use cases where federated file systems are. I can think about a few.
Yes. So one of the paths on being ubiquitous is, as Steve talked about earlier, today we use spectrum scale under the hood. Part of our vision going forward is to be file system independent, right? So you just think about it that way, right? It sort of picks up, PHO, on the question you asked.